Good morning, all of you. In this session, I'm going to explain about centroid and center of gravity. And also I will explain how to locate the centroid or center of gravity of the L section and inverted T section. I will explain in this session. First of all, I am going to explain about introduction about centroid and center of gravity. What is centroid? Centroid is a point where whole area of a plane lamina is assumed to act. Okay. Centroid is a point at which the total area of a plane figure like rectangle, square, triangle, quadrilateral, circle is assumed to be concentrated is known as centroid of that area. Centroid is always represented by C or CG or simply G. The centroid and center of gravity are at the same point. Center of gravity of a body is the point through which the whole weight of the body acts. A body is having only one center of gravity for all positions of the body. It is represented by the symbol CG or simply G. Centroid indicate the center of mass of a uniform solid. Lots of construction applications and engineering applications to design things so that minimal stress and energy is used to stabilize a component. These are some examples for centroid. Here you can observe, to lift this load, we are using a crane. For balancing this load, here the centroid or center of mass of this mission is very important. For stabilize the equipment. In civil constructions, it is very important. Centroid or center of gravity is very important for estimate the behavior or predict the behavior of the structure. The concept of centroid and center of gravity is very important in civil construction. In mechanical field also, the centroid or center of gravity is very important to avoid the accidents. These are some civil constructions, civil structures. For design of these civil structures, we need to design these civil structures on the basis of centroid. To design the civil structures for supporting, we will need to know the weights of the structure. Okay, weights of the structures, beams, pillars, as well as the locations where the resultant force representing these distributed loads. This is the simple example for a centroid or center of gravity of a rectangular lamina or square lamina. The center of gravity of a rectangle or parallelogram is at the point where its diagonal meet each other. Okay, these are the two diagonals. So the centroid or center of gravity of a rectangle always lies at intersecting point of a point of diagonals. Yeah, let's capital B is the base of a rectangle, D is the depth of a rectangle. Okay, then the centroid of a rectangle always lies half of the base and half of the depth. Okay, now this is a example for circular lamina. Okay, the center of gravity of a circle is at its center. Okay, the center of gravity or centroid of a circular lamina is at its center. The center of gravity of a triangle lies at the point where the three medians of the triangle meet. So here you can observe the centroid or center of gravity of a triangle always lies half of the base and 1/3 of the height from the base and 2/3 of height from apex. For right angle triangles, you have to consider 1/3 of base and 1/3 of height from right angle corner. Now this is a semicircle. The centroid or center of gravity of a semicircular lamina always lies 4r/3 pi, 4r/3 pi from base and r radius from edge. Here you can observe there is no change in position of centroid or center of gravity. Okay, 4r/3 pi from base and r from edge. Okay. Now this is a quarter circle. The centroid of a quarter circle always lies at a distance of 4r/3 pi, 4r/3 pi from right angle corner. Okay, 4r/3 pi from base, 4r/3 pi from vertical side. Okay, this is a right angle corner, so you have to consider 4r/3 pi, 4r/3 pi distance from right angle corner. Okay. Here also there is no change in position of a centroid or center of gravity. Okay, these all are the simple figures, centroid of simple laminas. Okay, now I am going to explain about these two problems. How to locate the centroid or center of gravity of a L section and T section. I will explain. Now locate the center of gravity of the given L section. Okay, this is a question. The base of a L section B1 is equal to 100 mm and the depth of base is 20 mm. Here this base is B2 equal to 20. depth d2 equals 60 mm. Okay, this is a given diagram. Now you have to locate the centroid or center of gravity of this L section. Okay, first of all, you have to select reference axis at the lower left hand corner. Okay, this is x axis and this is y axis. Okay, x and y axis is very important for taking the reference. Now the centroid or center of gravity now, first of all, you have to locate the centroid or center of gravity of individual sections. Here I consider this bottom rectangle as section 1, this vertical rectangle as section 2. Okay, now I am locating the centroid of the bottom rectangle. For that purpose, I am drawing the diagonal lines for locating the centroid of the bottom rectangle. Okay, so this is the centroid or center of gravity of the bottom rectangle. Okay, C1 is the centroid of a bottom horizontal rectangle. Now, in similar way, you have to locate the centroid or center of gravity of this vertical rectangle. For that purpose, you have to draw diagonal lines. Okay, here C1 is the centroid of a bottom rectangle. Okay, now x1 equal to base by 2 and y1 equal to depth by 2. So this is the position of a centroid with respect to origin. Okay, in similar way, you have to draw diagonal lines for this vertical rectangle. Now this intersecting point is a centroid of the vertical rectangle. Okay, C2 is the centroid of this vertical rectangle. Now x2, yeah, from y-axis, x2 is the distance of the centroid from y-axis. X2 equal to base by 2. Okay, base 2, b2 equal 20. Okay, 20 by 2. And also y2 is the distance of centroid C2 from x-axis. Okay, y2 is the distance of centroid C2 from x-axis. Okay, from x-axis, y2 equal to depth 1, that is the depth of bottom rectangle plus half of the depth of a vertical rectangle. Okay, d1 plus d2 by 2. So this is the position of centroid. Now x1 equal to b1 by 2. Here b1 equal to 100 mm. Okay, so 100 by 2 equal to 50 mm. y1 equal to d1 by 2. Here d1 from here to here, the d1 depth d1 equal to 20 mm. Okay, d1 equal to 20 by 2 equal to 100. 20 by 2 equal to 10 mm. Okay, here a1 a2 are the individual areas. A1 is the area of a bottom rectangle, base b1 and depth d1. b1 into d1 equal to 100 into 20 equal to 2000 mm square. 2000 mm square. And a2 is the area of a vertical rectangle. Here base 2 equal to 20 mm and depth 2 equal to 60 mm. Okay, from here to here, the depth d2 equal to 60 mm. Okay, so a1 is the area of a bottom rectangle, a2 is the area of a vertical rectangle. Okay, now x1 equal to 50 mm, y1 equal to 10 mm. In similar way, x2 equal to base 2 by 2, that is 20 by 2 is the x2 value, is the y2 equal to d1 plus d2 by 2 equal to 20, d1 equal to 20. Okay, d1 equal to 20 mm plus d2 by 2, that is 60 by 2 equal to 30 mm. So 20 plus 30 equal to 50 mm. Okay, x1, y1, x2, y2. Now here section 1 is bottom rectangle, section 2 is vertical rectangle. Okay, base B1 equal 100 mm, depth D1 equal 20 mm, base 2 equal 20 mm, depth 2 equal 60 mm. These are the dimensions, individual dimensions. A1 equal B1 D1, A2 equal B2 D2. These are the individual areas. X1, Y1, X2, Y2 are the distances of centroid from X and Y axis. Okay. Now you have to locate the centroid of the whole area. For that, you have to use this formula. Here, X is the distance of centroid or center of gravity from YY axis. Okay, YC is the distance of centroid or center of gravity from XX axis. Okay, now we have to determine these two values. Okay, now this is the formula for XC. Okay, X is the distance of centroid or center of gravity from YY axis. Okay, now here after substituting the value of A1, X1, A2, X2, you can get the value of XC. Okay, XC. Here A1 equal to 2000, A2 equal to 1200, X1 equal to 50, X2 equal to 10 mm. Okay. After subtracting these values, you can get the value of XC. XC equal to 35 mm. Okay. In similar way, YC equal to the distance of centroid or center of gravity of entire lamina from XX axis. Okay, here also you have to substitute the value of A1, A2, Y1, Y2. Okay, A1 equal to 2000, A2 equal to 1200, Y1 equal to 10 mm, Y2 equal to 50 mm. Okay, you have to substitute these four values in this equation. After substituting, you can get the value of YC. Okay, the distance of centroid or center of gravity of an entire lamina from XX axis is equal to 25 mm. Okay, this is the answer for the L section. Now I am showing the centroid or center of gravity of an L section. Okay. Okay, this is the given diagram, L section. Now, this is the X reference axis, this is Y reference axis. C1 is the centroid of a bottom rectangle, C2 is the centroid of a vertical rectangle. Okay, here C1 and C2 are the individual centroids. Whereas CZ is the centroid or center of gravity of an entire lamina. Okay, CZ is the centroid or center of gravity of an entire lamina. Okay, C1, C2 are the individual centers. Now CZ equal to, here XC is the distance of centroid from YY axis. Okay, and YC is the distance of centroid from X axis. Okay, so this is the position of a centroid or center of gravity of an L section. Okay, this is the final position of the centroid. C1, C2 are the individual centers. C1, C2 are the individual centers. Okay, CZ is the centroid or center of gravity of an entire section. Okay. Now coming to the another example, look at the centroid or center of gravity of the given T section. Okay. Yeah, inverted T section. This is the inverted T section. Base B1 equal to 100 mm and depth D1 equal to 20 mm. Okay, here the base B2 equal to 20 mm and depth D2 equal to 60 mm. Okay, this is the given diagram. So you have to locate the centroid or center of gravity of this inverted T section. Okay. First of all, you have to calculate the individual areas. A1 is the area of a bottom rectangle. A2 is the area of a upper rectangle. Okay. This one is a rectangle. So the area of a rectangle is base into depth. So B1, D1. These two are the dimensions for this bottom rectangle. B2, D2 are the two dimensions for this upper rectangle. Okay. Area 1, A1 equal to base into depth. Okay, so base B1 into depth D1, B1 into D1 equal to 100 mm into 20 mm equal to 100 into 20 equal to 2000 mm square. Okay, this is the area of a bottom rectangle. Now A2 equal to base B2 into depth D2. Okay, B2 equal to 20 and D2 equal to 60 mm. So the area of a upper rectangle A2 equal to 20 mm into 60 mm equal to 1200 mm square. Okay, these two are individual areas. Now you have to consider reference X and Y axis. Okay, always you have to prefer X and Y axis at the lower left hand corner. It is better. So this is Y axis, this is X axis. Okay, now this is the origin. Now you have to draw a diagonal line for locating the centroid of a bottom rectangle. Okay, so this intersecting point is the centroid of a bottom rectangle. Let C1 is the centroid of a bottom rectangle. Okay, now x1 is the distance of centroid C1 from YY axis. Okay, x1 is the distance of centroid C1 from Y axis. Okay, already we know that centroid of a rectangle always lies at the midpoint. That is half of the base and half of the height. Okay, in similar way, y1 is the distance of a centroid from x-axis. Okay, y1 is the distance of a centroid C1 from x-axis. Okay, y1 equal to half of the depth. Here d1 equal to 20 mm, so 20 by 2 equal to 10 mm. x1 equal to 100 by 2, that is 50. y1 equal to 20 by 2, that is 10. Okay, x1 and y1 are the distances of centroid from x and y axis. Okay, now in similar way you have to locate the centroid of this vertical rectangle. For that purpose you have to consider diagonal lines. Okay, this intersecting point is the centroid of a upper rectangle. Okay, let C2 is the centroid of a vertical rectangle. Okay, now x2 is the distance of centroid C2 from y axis. Okay, x2 equal to here x2 equal to x1. Okay, because this is symmetric about vertical line. Okay, that's why x1 equal to x2. Now y2 is the distance of centroid C2 from x-axis. Okay, this is y2 is the distance of a centroid C2 from x-axis. So here y2 equal to depth of a bottom rectangle plus half of the depth of a vertical rectangle. Okay, y2 equal to d1 plus d2 by 2. Now here C1, C2 are the individual centroids. Okay, x1, y1, x2, y2 are the distances, corresponding centroid distances. Here x1 equal to base, half of the base. So b1 by 2. Here b1 equal to 100. So 100 by 2 equal to 50 mm. y1 equal to half of the depth. That is a d1 by 2. d1 equal to 20. 20 by 2 equal to 10 mm. Now y2 equal to d1 plus d2 by 2. Here d1 equal to 20, d2 equal to 60. So 20 plus 60 by 2. 60 by 2 equal to 30. So 20 plus 30 equal to 50 mm. Okay, y2 is the distance of a centroid C2 from x-axis. In similar way, x2 equal to x1. Okay, x2 equal to x1. Here x1 equal to b1 by 2. So x2 equal to x1 equal to b1 by 2. Base 1 by 2. Okay, you have to add this gap plus half of the base 2 by 2. b2 by 2 equal to 10 mm. 10 mm plus this gap. Okay, that value equal to 50 mm. Okay, now these are the dimensions for bottom rectangle. These are the dimensions for top vertical rectangle. This is the area of a bottom rectangle. This is the area of a vertical rectangle. Okay, x1, y1, x2, y2 are the corresponding distances. Okay, centroid. Distance of centroid from x and y axis. Now xa is the distance of centroid or center of gravity from y axis. Now you have to substitute the value of area 1 x1 plus area 2 x2. Okay, you have to substitute the value of area 1, area 2, x1 and x2. Okay, after substituting these four values, you can get the value of xc. Okay, xc equal to 50 mm. In similar way, yc equal to the distance of centroid or center of gravity from xx axis. Okay, from xx axis. A1 y1 plus a2 y2 by a1 plus a2. Okay. Now here also you have to substitute the value of a1, a2, y1, y2. This is y1, this is y2, a1, a2. After substituting these values, you can get the value of yc, distance of centroid from xx axis. Okay. So xc and yc are the distances of centroid from y-axis and x-axis. Now, now I am showing the position of centroid or center of gravity of an T section. B1, D1, and B2, D2. Okay. Yeah, this is the reference x-axis. This is the reference y-axis. So here C1 is the centroid, individual centroids. C1 and C2 are the individual centroids. So C1 is the centroid of a bottom rectangle. C2 is the centroid of a vertical rectangle. Okay. Here C1 and C2 are the individual centroids. But CG is the centroid or center of gravity of an entire lamina. Okay, for entire section. Okay. Now CG x, here the distance of centroid or center of gravity from y-axis is xc. Xc is the distance of a centroid from y-axis. Okay, that value xc equal to a1 x1 plus a2 x2 by a1 plus a2 equal to 50 mm. Okay, in similar way, yc is the distance of centroid or center of gravity from xx axis. Okay, yc is the distance of a centroid or center of gravity from x-axis. Okay, yc equal to a1 y1 plus a2 y2 by a1 plus a2. Okay, so this is the final answer for this problem. Okay, this is a inverted T section. Okay, inverted T section. Here C1, C2 are the individual centroids. Okay, C1 and C2 are the individual centroids. Whereas CZ is the centroid or center of gravity of an entire section. Okay, so this is the position of centroid or center of gravity of the T section. Okay, xc equal to 50 mm and yc equal to 25 mm. Okay. In next class, I will explain how to locate the centroid or center of gravity of an T section and I section. Okay, in next class, I will explain about these two problems. Okay. Here you can observe this is a rectangle. Okay, so the rectangle CZ is the centroid of a rectangle. X bar, Y bar are the centroid. X bar is the distance of centroid from Y axis. Y bar is the distance of centroid from X axis. Okay, so here you can observe the centroid of a rectangle or square always lies at a distance of base by 2, half of the base and a half of the height. This is the example of a triangle. Okay, here you can. This is a isosceles triangle. This one is a right angle triangle. Okay, the centroid or center of gravity of a triangle lies at the point where the three median lines of the triangle meet. Okay, this one also a right angle triangle. This is a circle, circular lamina. This is a semicircle. This these all are the semicircles. These all are quarter circles. Here in this example, you can observe only rectangles. Here there are only rectangles. Okay, so the centroid of a rectangle always lies at midpoint. Okay, or where the diagonals of this rectangle meet.